Hello and welcome to excelmasterseries.com. Today we're going to show how to use the Weibull distribution to solve problems. And we're going to do it in Excel. Let's take a look at the Excel spreadsheet. We'd like to remove the grid lines to make the spreadsheet easier to read, so click on Tools, then Options, then uncheck the checkbox next to grid lines, hit OK, grid lines are gone. Now the Weibull distribution is one of the principal tools used in reliability engineering. It's often used to model time to failure for parts and has lots of other applications in finance and climatology. Now let's take a look at a problem that's going to be solved with the Weibull distribution and also solved in Excel. So if we scroll down our page, we can see the problem, and the problem reads as follows. Calculate the probability that a part will fail at time t equals 2 if the part's failure occurrence is Weibull distributed and has an alpha of 0.5 and a beta of 4. Let's take a look at the Excel formula we're going to use to solve that problem. There are 4 different parameters: x, alpha, beta, and cumulative. The first parameter, x, is the value that the function is being evaluated at. The problem says calculate the probability the part will fail at time t equals 2. So x is set at 2 in this problem. Second parameter, the alpha parameter, is the shape parameter. If the alpha parameter is greater than 1, the failure rate increases over time. The part wears out. If the alpha failure equals 1, you have random occurrence part failure. If the alpha is less than 1, the failure rate decreases over time, and that suggests the high infant mortality type of part failure. In this problem, the alpha is set at 0.5. And the third parameter in this problem is the beta. Beta is known as the scale parameter. And in this problem, beta is set at 4. And the fourth and final parameter is whether or not we're using the cumulative distribution function. Now the problem says calculate the probability the part will fail at exactly time t equals 2. That uses the probability density function, not the cumulative distribution function. So cumulative is set at false. Now putting all the parameters into the XF formula gives an answer of 8.72% that the part will fail at exactly time t equals 2. If we look at our interactive Excel chart, which is fairly simple to make, if we put the cursor right on the chart above time t equals 2, we'll see that the chart's value agrees with the value we calculated, 8.7% chance that the part will fail at exactly time t equals 2. This is the probability density function. This is an interactive chart. You can easily make it, and at the end of this video we'll give you instructions on how to purchase an e-manual showing you how to make charts for all the popular distributions and how to do all of these calculations in Excel. We're varying the two parameters, alpha and beta, and watching the changes reflected. Now if we calculated time up to time t equals 2, cumulative is set at true, and now our answer, there's a 50.69% chance that the part will fail up to time t equals 2. Looking at our interactive graph, if we put the cursor right above time t equals 2 for the cumulative distribution function, we see the chart's value, 50.69%, agrees with our calculated value. If you would like to master MBA level statistics in Excel, check out our Excel Statistical Master series of e-manuals at www.excelmasterseries.com/emanual.php. Thank you very much and goodbye.